Hello everyone. Tonight I'm actually making this video to show you how to troubleshoot a few things on your Polymoog. This is some very common things I've found over the years working on these Polymoogs, and this can actually save you a lot of time and a lot of money too, as that matter goes. Some of the common things I've found, besides just complete failures altogether, is actually that your tantalum caps short out. And tantalum caps, these little orange guys right here, now these have already been replaced on this board. And as you can see, they're replaced with these orange colored capacitors, which are normally this black. Factory they were black, and they're 10 microfarad by 10 microfarads at 20 volts. And these commonly, I don't know why, but these right here tend to short out. And I'm not sure if it's caused by voltage spikes or if it's actually just a lifespan of the component. But anyways, tonight I'm actually going to show you how to check to see if any of your boards are shorted. If you lose a voltage, or if you don't know if you've lost a voltage, there's some ways you can actually test this. So first of all, I'm going to show you kind of what the tools you'll need. One of the biggest tools you'll need is actually a multimeter, like I've got here, or something equivalent to it. This is actually a Fluke 76, which these aren't cheap. This is about a $140 meter. But you can actually go to Walmart and buy one of these as well, and they're only like $14. It's made by General Electric, I think, and it'll work just as good as this. This is just one I have. This is just a really nice one I have. That it's actually an auto ranging meter, which means I can hook it up and I don't have to sit here and select different ranges that it can read in. Whenever I set a voltage up or ohm reading up, it'll actually tell me exactly, and it'll calibrate itself down to meet the part value or ohm rating or voltage rating, which is really handy when you're actually doing this a lot. But for your case, if you just want to go to Walmart or wherever and get a good cheap meter, that'll be great. So you'll need a multimeter. And I highly recommend, before you even take the cover off a Polymoog, I highly recommend you go to Radio Shack and get you an anti-static wrist strap. This is something that will save you a lot of headache and once again, a lot of money. What this does is basically you put it on your wrist and you clip this up to like ground, which in this case, I'm going to actually just go and show you this right quick. What this cable basically does, let me explain what the anti-static strap does basically. It's just like it's called, it's anti-static. It pulls static off your body to keep you from releasing static into components on boards. And static can be very, very deadly to electronics. In fact, most failures are caused by static discharge. Now, not necessarily in Polymoogs, but if anybody's handled them before and they didn't have anti-static straps, they could actually touch one of these chips and actually send thousands of volts to these components and just break them down. And so this can definitely save you a lot of time and a lot of money. So basically, what I'm going to actually do here is I'm going to show you how to hook one of these up, because there's actually one way I highly recommend people do it on the Polymoog. Is once you remove the cover, is actually plug your power back in. I know that sounds strange. I know most people tell you right the opposite. Always leave it unplugged when you're working on it. But in this case, actually plug it back in. Just make sure you do not hit the power switch. You do not want to turn this thing on when you're working in it. Of course, it's low ampage, but I think it puts out like 750 milliamps, which is still enough to kind of hurt you, and low voltage. But basically, what you want to do is you can actually take this strap, and usually it comes with a gator clip, as you see here. It clips on. Actually, just clip that onto your chassis over here, your metal part of your chassis, and you can actually strap this onto your wrist with the wrist strap, and now you're set to go. And one reason why I say to leave this thing plugged in, because what this does is actually when I unplug it here, you've actually got a 3-prong power cable, and the third prong is actually an earth ground connection. So basically what that does is when you have this thing plugged in, your whole chassis is referenced to earth ground now. So that keeps anything from floating or anything like that. So now you're directly to earth when you're strapped here, which is what you want, to make sure you don't have any static on your body when you're touching this stuff. But anyways, with that said, I'm going to set this to the side because I always wear one. But for what I'm going to be doing tonight, I'm not going to be touching these boards. And I'm going to be very careful working around them here because I can't really do my video camera with that thing strapped on me. What you'll do is basically on the Polymoog is if you got a 203A Polymoog, you've got two accessory jacks on the back. As you can see here, these two jacks here. You got a yellow wire, a black wire, and a red wire. And basically the yellow wire is your your plus 5 volts. The black wire is your negative 15 volts, and the red wire is your plus 15 volts. And you can lose any of these voltages and still have the other ones there. And that can cause all kind of weirdness, and you know, this is going to be an easy way to see what you've got going on. So what you actually do is you'll take your multimeter, and of course I'm going to stand mine back up over here so I can do a good video of it. You'll want to set it to ohms. And basically ohms is this little horseshoe symbol. It's like a little horseshoe. The omega symbol as well. And you can actually just turn that over to that. You'll see mine actually says infinite, which means there's nothing connected. And basically if I short out the leads, and basically what ohms is doing for anybody that's not an electronics person and don't know what ohms is, that's basically where you're checking resistance values of components and basically how close they are to a short or ground. But basically right now I've actually got my leads shorted together, as you can see. 0.3 ohms, so that's definitely not good. That would be what I would consider a very low ohm reading, very low. And in fact, that's a short. That's what we call a short. But now what I'm actually going to do is I'm going to show you what it looks like and how to connect your leads to test your voltages, or even test your resistance in this matter. Okay, so before I hook up, always make sure your power is off in this when you're checking ohm ratings, because your meter does not like to have voltage through your ohm setting. Because actually what you're doing is you're actually feeding a little small voltage out of your meter that's actually traveling through all these circuits when you check this. And if you turn on voltage, and you're driving voltage into your meter, and it can damage things in your meter. So what we're going to do first is take your negative lead, your black lead, and actually connect it. As you can see here, let's see if I can get in where and look where I'm going here. You want to connect that to your ground line, which is your green wire. And you can connect either connector, it doesn't really matter. Of course, like I said, if you have a 280A Polymoog, you've only got one connector. But you can see now I've got that connected to the green wire on that connector. I'm going to take my red lead, if I can find out where I am. I got the zoom way out here. You have to excuse my camera work here. But anyways, now I got the plus lead. Let's go to our plus 5 volts line, which is the yellow wire. As you can see, you can just clip it on the back line. As you can see, that's the pin of that connector. I've got it connected to the metal of it doesn't really look at. Let me make sure I'm right there. Yeah. So now we're connected onto the pin of that connector on the plus 5 volt line. And looks like we got to open. So let me check this right quick and see if I've got a good connection. There we go. As you can see, I'm reading about 277 ohms, which is good. That seems low, I know, but that's actually accurate. So you got 277 ohms there, which is what you'd want to see on the 203A. I'll make a video also for the 280A to show you what I read on it. On the negative 15 volts, I read 651 or 650 ohms, which is good. Because this is a working Polymoog, by the way. This is what I've been restoring for David Coltai. Now we'll go to the plus 15 volts. You can see I read about 214 ohms. Oops, wrong way. 214 ohms, okay? So that's what you'd normally read on your Polymoog. And of course you can see how I'm doing that. I started at the yellow wire, went from here to the middle pin there, which is your black wire, which is negative 15 volts. Now I'm on the plus 15 volts, which is the red wire. And that's how I'm actually checking the voltages, or checking the resistance, sorry. Now you can also check voltage in the same way. But before we check voltage, I'm actually going to demo something here for you. I'm going to take this cable here, which is just a straight cable with gator clips on each end. And I'm actually going to short out one of our tantalum caps here. I'll short right across one of our caps. So now he's actually straight shorted across. You can see I'm still reading fine on my plus 5 volts, which is normal. That's what you'd actually see. And what this would actually do right now, if this was powered up, is you'd have it powered up, your lights and everything would still be working, but you'd have no sound. And you'd probably actually hear a buzz, just a loud zzz kind of sound on your output. And what you'd also see, if you had the cover off this, is you'd actually go over here to the power supply and you'd see one of these guys, these little resistors sticking out, which these are newer because I've actually already replaced these. Of course you can see that one's already burnt a little bit, because this is one of my test power supplies. And you'd see one of these smoke or open up eventually. And basically that's what that does. It's a shunt resistor and it protects your power supply, and those basically work like little fuses. And so one of those would burn out, open up, and it would cause your 15 volt regulators and everything to be safe, which is what you want. You don't want this thing to sit here with a short and just smoke and burn everything out, which is exactly what its job is for. But now if we go to the negative 15 volts, we'll see what we have here, which we should still be okay there. And we are. You can see we still got like 645, which is a little lower, but not considerably lower. If we go to the plus 15 volts now, whoops, let me find clip on here. I'm trying to look and do two different things. Now you can see there I've got a short, which is not good. That means your negative 15 volts is connected straight to ground, which basically means you're just driving straight to ground, which will pull all kind of current and just basically just demolish your power supply. And there's a way you can actually test to see which board your short is on. And this is a really cool thing about the Polymoog, because the engineers that designed this did some really good little things for you on this unit, unlike some of the other synthesizers I've worked on. Basically you have a circuit board, you have all these circuit boards, and they all have a power connector, as you can see here. And there's a way to identify your power connector if you're unclear. If you look at this connector here, it's actually clear versus white, which all these are white. You can see all the other connectors are white color except for this one, which this is a power. This means this comes off your power supply and feeds voltage throughout this board. And you've got this on every board, as you can see. Every one of these clear ones are your power connectors. And basically there's a simple way to do this. If you're unsure which board is shorted, you can actually unplug each board until that short goes away. So of course we know the short's here because I got this jumper. But just to show you how this would work is I take this connector. Let's unplug it. Let's say that we're on our last board here. Let's just unplug it and see what this does for us. Oh, there it is. So what that shows, it shows the problem is in this board somewhere. So we've got a short in this board. And so there's your problem. So now if you had to go to a technician and say, my Polymoog doesn't work, you can say it's on the top right board. And then you've got narrowed down, you got the troubleshooting part narrowed down very little. And instead of the technician having to go in and look at all this and charge you hours and hours for looking at circuit boards, which will be a lot of money. Now we've just narrowed it down to one board, and that's how I do a lot of my troubleshooting in these things, is simply by taking one object and seeing if I can find out what's the culprit. But also, if I plug this back in, we'll remove our short here. And once again, you don't need this. This was just to show you what a short looks like. Let's plug in this connector again. Alright, and now what I'm actually going to do is I'm going to show you how to check your voltages. So now what I'm actually going to do is I'm going to go here to your DC signal, which is DC voltage, which is here. It's a straight line. As you can see, DC is always represented by a straight line because that's a DC, direct current. Because AC has cycles. It has a 60 cycle or 50, has 60 hertz or 50 hertz depending on your location, and it's always represented by a sine wave signal, where DC is just a straight direct signal, so you always have a smooth signal there. So now what we're going to actually do, we're going to actually check our voltage, and you check it the same way as you do that. We'll start with the 5 volts again. So same connection. Let me actually unplug that, and we'll start with the 5 volts. So let me go here to the 5 volts. Sorry about my camera work there, guys. Alright, so now I got that connected to 5 volts, and now I'm actually going to turn this thing on. So while watching that, I'm going to flip this guy on. You can see, aha, there's our 5 volts. So that shows that we got our 5 volts, which you can actually see because all the lights work. Everything switches. So that shows you too that your 5 volts is there. So now let's go over, and I'm actually going to check the negative 15 volts next, which is like this right here. Now be careful not to touch in between these. It's not easy doing holding the camera. Okay, and you can see now we've got our negative 15 volts, which you can actually see the negative sign, and that shows our negative 15 volts is there right on the dot, which is great. Now we'll go to our plus 15 volts. You can see it's 14.98, which is still fine. That's still well within the spec, the voltage. And of course, if it is a little low, you can actually calibrate it, which I'll show you on some other video. But basically, that's how you can actually check and see what's going on. So if you're missing one of these voltages, then you know that you've got a problem with one of these boards with that voltage. So then what you'd actually do is tell the technician that, hey, I've got I don't have any plus 5 volts, and you know it's got a short on one of these boards, or so forth, so on. Or if all your ohm readings read correctly and you still have a voltage, it's probably your power supply, which is this guy that sits right back here. And of course, this is the Faratron model supply. You also have a Moog version in some of the later Polymoogs. But anyways, that's just a quick little test there for you, and hopefully that'll help somebody out that might have a Polymoog setting around. And that's just a quick way to actually test and troubleshoot. You don't really have to be an electronics expert to test that, but I always recommend do not work on these boards unless you do know what you're doing, because you can do a lot of damage on these boards. And so always leave actual repairs, desoldering, soldering. If you don't know how, don't do it, because you can do a lot of damage on these boards. But I also recommend, if you're wanting to learn how to solder and desolder, start off with Radio Shack circuit board and practice desoldering and soldering before you even go into anything like this, because I've actually had some of these Polymoogs come through, or other synths for that matter, and somebody's tried to do things that they didn't know what they were doing, and it just ended up being a lot worse, and actually ended up costing them a lot more, because you have burnt tracings. You can actually lift all these little tracings. You can burn the circuit board itself up, and there's a lot of damage you can do if you don't know what you're doing. And so I always recommend leave actual repairs to a technician. But definitely this is something very easy to do, and it can save you a lot of money, a lot of time, as I said earlier. And it's something that an average Joe can do if they know how to use a multimeter and know how to check some things. But anyways, guys, I hope this video helps you out. And if you have any questions, or if you have a Polymoog you'd like me to look at, feel free to message me, and we'll go from there. Take care.